Hello and welcome to Simple Economics Bertrand Competition tutorial. First we're going to look at the monopolist model and run through that quickly, and then we'll go through various types of Bertrand duopoly, starting with the standard model, then with asymmetric costs, and finally with collusion. Okay, so in the monopolist model, the monopolist maximizes his profit, and he does so by setting quantity where the profit function differentiated is equal to 0. So maximizing the profit function. And as you can see, that's been worked out here. It's been checked with the second differential to make sure it's negative and that it is indeed a maximum. And then we have solved to find the quantity and the price. So the main reason for including this is because I've linked it into the example with asymmetric costs later on. So this just makes it easier to follow, and we can skip through a lot of the working out there. So the profit function is, you work out the monopolist profit by multiplying the price times quantity minus marginal cost times quantity, and consumer surplus is the area between the demand curve and the price level in the y-axis, that triangle there. And then total surplus is calculated by adding producer surplus, the profit, and consumer surplus. Okay, so firstly, the assumptions of the Bertrand duopoly model are that the firms are able to vary their output with no delay. This means that they can immediately choose their output level, and whatever this output level is, there is no capacity constraint stopping them from setting it. Consumers are fully informed of both firms' prices, and both firms produce one homogeneous product, so consumers can't differentiate between the products produced by each firm. Okay, so in the standard model, both firms are competing on price, so there's always an incentive to undercut the other firm and steal the whole market share should one firm set a price higher than the other. So therefore, it's a perfect competition model, and they both set price equal to marginal cost, which in this case is 32. By substituting 32 into the inverse demand function and equating Q1 to Q2, you can work out that the quantity is equal to 12 for Q1 and for Q2. So by plugging in the marginal cost into the inverse demand function, we find that the total quantity produced is equal to twice what each firm produces. They produce the same amount, they face this symmetric cost function, so that's why we can sub in Q1 equals Q2, and from that we work out that Q1 equals Q2 equals 12. Given that neither firm has any market power in this case, there are no profits for the firms, and consumer surplus is equal to total surplus, which is equal to 288 in this case. Now, in the model with asymmetric costs, the two firms will face a different marginal cost each, and here we have one faces 16 per unit, and the other faces a marginal cost of 10 per unit. Therefore, the firm with the marginal cost of 10 has the power to steal the whole market share by undercutting firm 1, and he will therefore charge a price that is approximately equal to 16, but just below, marginally below, and steal the full market share. So effectively in this case, it becomes the monopoly profit that we saw in the first case back here. So what we have is we have profit equals total revenue minus total cost, and then we work out that Q in this case is equal to 8, and that price is equal to 48, and the producer's surplus, the profit, is positive, so he does have market power. Consumer surplus calculated to be 128, which is lower than in the perfect competition duopoly, and equal to the monopoly profit, of course. And total surplus is higher with market power, captures more of the market. So Next and finally, in the collusive case, the firms have an incentive to work together when they have symmetric costs to steal the full, to produce at the monopoly output level. And they'll do this together and split the monopoly profits equally. So in this case, we have the quantity equals the monopoly total market output equals the monopoly output of 8, and then they split that equally between them, produce 4 each, and the price is equal to the monopoly price. And profits are therefore split between the two. 256 divided by 2 is 128, and the consumer surplus is exactly the same as in the monopoly case. Total surplus as well. Now, this is only sustainable if in the infinitely repeated game a level of patience delta is the firms competing have a patience of at least delta. Okay, so we're going to work that out now, and both firms need to credibly play the trigger strategy in this case, so that the punishment is harsh enough for the firms to prefer to collude. Now, the level of patience is calculated by taking what would be earned in each period, which would be a half of the profit monopolist plus delta, so a discounted factor of the monopoly profit of half the monopoly profit plus delta squared times a half the monopoly profit, and so on, which is captured by 1 over 1 minus delta times the profit. And what this has to be greater than is the profit from deviation, which is the full monopolist profit, which would be earned if the firm were to deviate. So by solving this, we divide through by the monopolist profit on each side, and we get 1 over 1 minus delta times a half is greater than or equal to 1. And then by rearranging, you get delta is greater than a half. So the simple equation for this is that delta is equal to 1 minus 1 over n. That is the equation that captures this idea. And so for collusion to be sustainable in this case, both firms must have a patience of over a half, basically. Otherwise, the profit from deviation, the full monopolist profit, will be greater than the profit of the monopolist. Thank you.